Hey folks, welcome to the stream, and today we are going to look at heat displacement or dissipation rather. So with that in mind, we are going to have a look at our brazier, and we are going to see when it actually fires off light or heat and at what distance it actually fires as well. Okay, so with that in mind, we need to see when it fires heat. This is the activation. Okay, and it's on the overlap of the heat zone. Okay, so with that in mind, we're going to have to actually change this a bit, because we want it to fire off at a certain distance. So the idea here is that we've got our activation zone, we've got our heat zone, and what we want to do is get the distance from the center to the heat zone, get the maximum value, and then normalize it from the player to the center. So if you're right next to the brazier, it's going to give off maximum heat. If you're right on the very outside, it's going to give out minimum heat. Okay? So, with that in mind, we have a weird setting. Now, I didn't set this up, but anyway, we have a scale of 13.84. Now, the interesting part here is we're going to set up an event tick, right, just temporarily. So we'll set that up, and we're going to do a print string on that. And what we can do is we can get our heat zone, then we can return our bounds, right, and we can well, we can try each of these and find out what it actually says. Okay, so we'll try the sphere first, and we'll see what value that actually gives us. So we'll do that, and we'll press play. Okay, and we have 637. Now, the question is, that in actual units? Okay, I actually don't think so. Okay, so what I want to do is we want to click on the heat zone, and you can see that that is the much bigger thing. So what I'm going to do is I'm actually going to place a couple of items on this and find out what the distance is between them. Okay, so if we, I believe it's all classes, but we want the easiest way to do this, and I've got, my eyes are watering badly because the wife actually put in like the fragrance sticks that you light, and the smoke coming off them just goes for my eyes. And I don't know why I typed party, because it should be target. Oh, which reminds me, make this a bit better for you guys. Do we have one of these essence sticks still lit, because there's something going for my eyes here. Okay. Anyway. So we're going to type in target, and we're going to get a target point, right? And we're going to drop it right on that. Now remember, our value is 632, okay? So we're going to calculate, or we're going to look at the distance between that target point and that target point, right? So this target point is 2161. This target point, now is it, yeah, it's on the Y. So we've got minus 639. So that's about 400 and something. Okay, so that is not 600. Now that's not in the centre either. That's more like the centre. So that's 200. So that's 439. Again, if we press play, that's definitely not the difference, because that's 637. Okay. So we're going to stop that for now. And I'll tell you what, just to stop any confusion, I am going to delete this Firebrazer, just so that we're not getting any confusion. We'll delete that one as well, and we'll delete original versions of it, right? So we'll take these out, and that's now only the one brazier, and I'm pretty sure it's still going to say 632, 637, right? So that's not good. Okay. And we're going to close that. Okay. So the next thing we're going to do is we're going to go to our box extents. Okay. Then we're going to break the vector on that. And we're going to say Y. Okay. Then we're going to press play. 442. Now that is a lot more like what the difference between our two target points are, 442, okay? So we can click on this one, 639, 200, so that's 440. Okay, so basically we have the distance, okay? So what we can do next we know that this is the value we want, okay? And then what we can do is we can normalize it and right, we want to get we want to normalize in a range. Right? And the maximum is going to be that. Hi Dragon One Fortnite, how are you doing today? So we're going to normalize our distance between the actual mesh and the heat bounds, right? So we're going to get a value that's going to start at 0 and then it's gradually going to go up 0.5, 0.751, okay? And that's going to tell us exactly where we are as a distance to the player, okay? So we know what our range is going to be. Okay, so now what we need is our reference character actually we want to normalize it the other way around. We want to normalize it from the biggest, from the high number to the bottom number. Okay. And what we're going to do is we're going to get a reference character. This is us prototyping for, we're going to get actor location. Okay. We're not going to move to location. We're going to get the actor location. Okay. And we're going to get distance between 2 points. Okay. And we're going to get self, which is the brazier, and we're going to get actor location. Okay. And this is the number here that we want to plug in there. Okay, is my mic not clear enough, or if I make an AI system? Yes, I can make an AI system. If you want me to show you one, let me know, and I will show you after I get the first part of this done. I will show the AI system for my wandering animals, or at least the first iteration of it. Right, so we're going to do a print string again, right? But this time we're going to print out the normalized value. Okay? So we shall save that, and it should give us now when we hit 1, we are basically within the heat. And actually, we want to change these around. I was right in the first place, believe it or not. Okay. So this should give us a 0, except it doesn't. Okay. Okay, let's return back to this. Once we have answered Dragon Juan Fortnite and let him see an AI system. So what you've got to remember here, Juan, is the AI system isn't really a standalone system. It incorporates a few things, including character movement, animation blueprint, and the AI parts, which is made up of 3 different parts, which is the AI controller, the AI blackboard, and the AI behavior tree. Okay? So we can have a quick look at it for you. Right? Now, this is one for a goat, but it does actually relate to everything. Now, these are all tasks inside the behavior tree, but here is our controller, right? Which we begin play and do some stuff. Then this is when it perceives somebody, basically the player. Okay, and then when it stops perceiving. And that's it for the AI controller. But we have a blackboard which has these variables set up in it. Okay, we've got status, new destination, has target, walk speed, run speed, behavior cooldown, is shot, is dead. Okay, then we have a behavior tree that looks like this. So it goes down and checks if it's shot or dead. If it gets shot, it basically sets its status to shot, then a new destination, and it moves to it, which is like what it does is basically when you shoot the animal, it wanders off. It doesn't immediately die, okay? Because animals don't immediately die just because you shoot them, right? They just run away and then basically die of the wounds, okay? Then here we set the status to dead, which does some special stuff. Basically it spawns in a dead animal, and basically otherwise it selects a status. Now that status can be various things, like idle. It can be moving to a new position. It can be moving to a short new position, right? Because animals tend to just move short distances while they're eating and stuff. So they don't always just walk like half a mile and then do something. They're more likely to do a little move. Then they can be grazing, they can be resting, they can be alerted, and they can be sleeping. Okay? And each of these things do separate things. Okay? This is a first pass on it and it does work. So I can show you that, because if we look over here, we have a goat here, right, in the middle of the screen there, just to the left of the boxes, and we can basically watch it, right? So if we move over here, there you can see, now I might have just alerted it, right? So it's going to run away, directly away from me, right? Now what we can do now is we can watch it again. We can shoot it, but I'm not going to. Right, so there it's resting. You saw it went, and it's going to do something else. Right, you can see that it's doing something else in the behavior tree. Right, so if we drag our behavior tree and have a look, we can see that it's currently waiting to set a task. Then it's going to do this task, then it's going to set a new status, right? So you can see this, it'll go to here, it'll do one of these. It'll go back to here, then it'll do one of these. It'll go back to here, and then it'll do one of these, okay? That's basically how it works. It does a thing, like goes to sleep, or rests, or grazes for a certain amount of time, then it'll select a brand new status, and then it'll do that thing, okay? So you can see that it's went down to sleep, or it's resting. It'll get back up, it'll decide to do something else. It's basically resting again, I think. Okay, so it just does that randomly. Now, if I actually sneak up on it, right? It also uses the AI to hear me and see me. Right, so there it's there, it's ran away again. Or maybe it hasn't. But there it is. And there it goes, it runs away from me. Okay? And that, my friend, is an AI system. So, it's not a hugely complicated thing to do, but it's in the same breath, it is not the simplest thing to do. Okay? So, we need to find out why our value here is kind of weird. Now, the max range between that and that, we should basically clamp it. Okay, so what I'm going to do here is I'm going to clamp this value between 0 and 1. Okay. And basically this value here, 2.13, okay, and then that's going to be clamped, disable breakpoint, so it should give us a value of 1. Okay, it should give us a value of 1 until we move into range, and there you go, see? But what we actually want here is the other way around, right? We want it to be, and if we go to there and to there, I was hoping for it being the other way round. Alright. Which is interesting. I wonder if we multiply it by -1, right? And we do that. I don't think this is going to work, but we'll try it. Yeah, it's still giving us a 1. And that's because, and it's still giving us -1, right? So if we bring this in as the minimum, and that's not going to work either. so right, so this is just not going to happen. Alright. Now, the interesting thing, I'm just wondering in there if there's like a it's not interpolation, that's for sure. Normalize in place. Huh. Anybody know if there's like an invert or normalized value? Right, so it's not going to be there. Okay, so it's nothing to do with that. Right, so the interesting thing here is we want an inverted value for the normalized, right? So when we get a 1 we want a 0, and when we get a 0 we want a 1. Okay? That's what we want here, but that's not what is actually happening. Right, I'm still convinced that it should be this number here. Right, it should be this number 400 to 0. Is the normalized value. But that should be saying 0. Now it does work. Right, and if this is the closest we can get, right, it's actually from the closest we can get is this. So we need to get the bounds on that. And then we need to break this vector And it doesn't actually matter which one we go for here. If we say on the Y, we can print this out, right, and find out what this value is. Okay, so that's what we'll do. It's 100. So the closest we can get to it is, let's say 100, but we'll use our target points to actually check that, right? So what we'll do is we'll move this right on the line, and that's going to be from here. So that's 195, and that's 322. Now we can see there that it's way off. Okay, so it's 296, 196, right? So it is 100. Okay. So the minimum range is that, and the maximum is the other one, and the value we're going to get is the difference between the two. So if we move right up to as far as we can, we should get a 0. And it's as near as damn it. Okay. So I'm going to do a quick Google search. And I'm going to say invert normalize. Right, so there is a calculation here, and what it says right. So we get this value, then we get this value, minus this value, then we get this value and multiply it by this value, and then we get this value and add this value, and plug that in, and let's see what numbers it gives us. Four, 2 to 130. Okay, so that didn't work. So unless this is the normalized value here, so $130. Now we use this number. What did we get? Try this out again, see what we get. So we're getting our 442 down to our 130. Okay, so let's try something. If we normalize that, and let's say we put in 430 to 130, right? And try that. Okay. Right, that should go down to pretty much 0, which it does. So it doesn't look as if you can. There must be a way of doing this. There must be a calculation here that I'm missing. But anyway, if you're enjoying the stream, guys, hit a like, subscribe. I'm going to have a quick break, grab a drink, and I'll be back in 2 minutes. Check out the description for links to Discord, Patreon, and my previous game on Steam. And I shall be right back. Don't go anywhere. Okay guys, I think I've figured out a better way of doing this. One that will actually work. Okay. So, we're going to take this out. We're going to get this clamp number here. We're going to remove that as well. Right, we're going to get this number. Then we're going to take away 1. And then we're going to multiply it by -1. Right, so we're going to get float times float, and then we're going to do it by -1, and then we're going to plug this in. Okay, and press play. And there we go, we're getting 0, which is exactly what we want. Right, and now we're getting values up to pretty much 1. Okay, and that should do us. So that's going to now, that calculation there gives us our distance, okay, from, in a normalized value, from the player to the object. Okay, and we could tidy this up, right, and add it to a function library. Okay, so we basically just pass in actors. We can either pass in actors or vectors or this number here, and then basically get it to pump out a value at the end, which is a normalized version of where we are between one and the other. But what I want to do here is I want to enable a breakpoint and run that again, because I want to see a couple of these values. 442, 100. Right, and this distance here we should be able to get to 100, but it doesn't appear that we are. So what I'm going to do is I'm going to move her to here, then I'm going to hit this breakpoint again, right, and then we're going to see this position here, and it's 130. Now that shouldn't be true, but I know it can be, and I'll tell you why. Right, this is because our mesh has an extent as well. Right, now we're taking in the extents value here, we're taking that into account, right, but we're not taking into account the extents of our mesh. Okay, so what I believe is we need to get a copy of our reference character, right, then get our mesh, then get component bound, right, and what we'll do is we'll check. Now I'm expecting this to be around about 30, but we'll soon find out. So we'll press play, and it's actually 96. Now that is actually okay. And what we want to do here is get our extents from here, and we're going to get our X extent. Now if my thought process is correct, this should be about 30, which it is. Right? Now, why it's changing, I'm not 100% sure. Actually, I'm sure. Let's check the Y and see what the Y says. It says 35. Okay. So in effect, we'd be best using X, right? Then we can break that, and what we're actually going to do here is we're going to bring this out a bit. We're going to minus this. Wait a minute. We plus this. That goes there. That goes there. We can delete this number here. And this one, we actually minus it. So we go with that and we say minus. And we go X again to there. Then this goes in the minimum and this goes in the maximum. And then this number here goes in there. Okay. And there you go. So that gives us our value, right? So we've done our value. Okay. Which is all rather interesting. Now, the interesting thing here is really, I would say it's only the heat that's actually ever going to use this function, right? Where I'm calculating a negative or a normalized distance, right? And our next thing we need to find out is blend out original atmosphere, right? So what we're doing here is we're creating an infinity weather and an atmosphere. Okay. So now if we are overlapping, we've got a ref character, okay? So what we're going to have to do this blend duration, how long does this set for? Ten seconds. Well, that's a bit on the much side. And I'm wondering, okay, so the interesting thing here, right, is it takes 10 seconds for it to blend out. Okay. Now what I'm going to have to do here is check out what we actually need. Okay, it looks to me like this needs to get turned into a function that runs X amount of times, like let's say every 2 seconds, right? So what I'm going to do is I'm going to write what we'll actually do here is we'll do a function, right? And we'll say update temperature based on proximity. Okay. So we're just going to need a new atmosphere passed in, so that's BS infinity atmosphere. Okay. So we go back to our function and we're going to add an input. And we're going to call it new atmosphere. Okay. And it's an infinity atmosphere. Okay. And then what we're going to do is we're going to grab this. So we're going to copy that. We're going to say paste there. Then this is going to get deleted. This is going to go in here. That's going to go in there. Right? So we'll tidy this up. Okay. We'll go back to our event graph. Okay, and we'll actually do a custom event. We'll just do this custom event. And we'll just call it proximity. Okay. Then we're going to get this. Except for this part, we're not going to do that. Right? Then we're going to collapse nodes. Actually, we're not. Right, so that's going to give us our number. We're going to turn this into a function, right? So we're going to say collapse to function. Okay. So we'll say return normalized temperature. Okay. And what we're going to do here is this. In fact, yeah, that's what we'll do. We'll say Atmos. Okay. And we're going to do another normalized. Let's say normalized to range, and that's going to be minus, I think it's minus 50 to 20. Okay, and our value is going to be that, right? And then we're going to get the atmosphere. Then we're going to say set members. Okay. We're just going to set the temperature. And the temperature is going to be this value here. And then we're going to set our atmosphere. Whoopsie doopsie. That's going to go there. Right? And this node is going to go, I don't know why it did that, but anyway. So we're going to drag that to there. Then that is going to go to there. And that is going to go to there. Okay. We'll drag that up. I'll tidy this up in a minute. Just want this working. Save that. Okay. So we go back to our event graph. And what we're going to do is we're going to grab that, we're going to plug that in there, and then we're going to call our function which is this one. Okay. And that is going to go there. And that is going to go there. Okay. And this is basically going to go away. Right. And the first thing we're going to do here is clear timer by function name. And we're going to run proximity. So this is the one we're going to clear. So we clear that there. Okay. And we do that. Then we're going to move that out a bit and then move this up to there. And then we're going to start timer by function name. Apparently we're not. Timer. Set timer by function name. Okay, whatever. So we're going to say proximity. Okay. And we're going to run this every 2 seconds and we're going to loop it. Okay, so when we clear the timer, it's going to stop it and then it's going to basically blend out and take us back to our normal original thing. This one is going to go in here, but what we're going to do is we're going to replace this and we're going to replace it with a 2. Okay. Let's see if it works, shall we, guys? Apparently not. Okay. Apparently not. So the question is it running it? And the answer to that apparently is no. Okay, so we've got a bit of code in the wrong place. Oh. Yeah, I need to switch it on. I need to switch on the brazier for it to actually work. Okay, that makes a bit of sense. So, let's do this then. Okay. We've got temperature. Okay. If we step back a bit. Okay, it's given us 20 degrees. which isn't right. Oh, I haven't spelt it right. Oh, an idiot. One little letter. One little letter. The interesting thing was, that's kind of fine. Right, so we'll try that again. Right. So, do it. Right, so our stuff is running now. Okay. And we are setting the atmosphere. Okay. I've no idea what happened there. I wonder why that's 0.7 degrees. Okay. So let's try that again, shall we? Or let's see what our infinity number is given us here. Alright. So that's 0.71. How can it be giving us back 0.71? Right, that says 0.1. Right? Right, so that's 0.4. So this isn't calculating the value. Right? So we can resume that, and then it's going to break again. Disable that, right? So it's quite a simple way of doing this, but we'll do it anyway. So we've got a 70-degree difference. Okay. Right, so we're basically going to delete this. We're going to get this number and we're going to multiply it. we're going to multiply it by 70. And then we're going to add it to minus 50. Then to integer. And in fact, we'll just no bother doing that. We'll just plug it straight in. Okay. And our next attempt, tell you what we'll do, I'm going to get rid of that event tick. Okay, so let's get rid of the event tick. Let's get rid of both of them. So we're going to save that. Okay. We're going to light it. Alright, I'm going to move away a little bit. I'm going to move away a little bit more. And a little bit more. And a little bit more. And by this time, yeah, she's well out of range, man. But yeah, there you go. We have a working version of heat proximity. Okay. And that is working really well. We're right up against it now. And we're at 19.9. 20 degrees. Fine. Absolutely fine. And I think I'm not going to leave it there. Right? And the next thing we are going to do is we are going to check out what our zombies look like, because there is zombies, and I'm not 100% sure which zombies we're actually going to use. I kind of haven't been told yet which we're going to use, so I'm going to have a look at these to see what they are, and I'm going to pop a quick message to my colleague to ask him what message Right, okay, so right. I don't think it's going to be that one. That one's a possibility, right? But I'm going to have to look at these ones, right? And we have Zombie Man. And we're doing some compiling of shaders here, which is fine. Okay, we're going to have to just let that do its thing. I'm sure it will do its thing in time. Okay. I'm going for the fact that he's going to use it might be Zombie Mutant, I suppose. Okay, so what does this one look like in reality? We'll have to wait and see. Okay. I'm not 100% convinced by that. So I think if it were me, I would be going with this one. Now, the question is, we have a ghoul bundle. Is it a ghoul? Maybe. What about a big ghoul? Nah, I don't think so. It's more comic more than anything else. We have the mutant animations. Death Idol 1 and 2 and 3. Right now, we should be able to retarget these. What about mutant dogs? Let's have a look and see what mutant dogs look like, eh? But we can retarget these to whichever mesh we're using, because they are humanoid, so yeah. Now, are these just individual animations, or do these come as? Do these come with an animation blueprint? Apparently they don't. they don't come with an animation blueprint. So we are basically going to have to create our own animation blueprints. Now, what about this stuff? We've got Zombie Man, and he has got animations, and he's got an animation blueprint as well. The unfortunate thing is that it's the standard animations, right? It's basically just your third person animations, so that ain't gonna look exactly very scary. Right, that's just going to be crap, because you don't have well, that's a bit naff. Okay, now that is textured, but it just looks really weak. It just looks kind of white, to be fair. So I've got to think that he's going to use this infected, right? Because the other ones don't really make an awful lot of sense. Right, so that one there. So we're basically going to have to plug in and retarget animations to this. Right? So we're going to go to here. Right? And this is the mesh. That's right. And I don't actually really want to do this until I can speak to my colleague and ask him what he wants. Otherwise, I'm just going to be taking up space here. So, I'm going to create a new folder, and I'm going to say animation, right? And then I'm going to create another folder, and I'm going to call it AI. Okay. Now we need our materials. We don't need the map, right? Because that's going to be crap. So I'm going to tell them that we're going to delete that. And we don't need all this third person crap as well. And this is basically coming from, that's okay, that's okay. And we've got 3 texture sets here. Right, so if we go to our mutant, this is the mutant, right? So that's no good to us. Right, right, these were just basic, yeah. Demo content can go. It's utter useless to us. Right, zombie mutant. Did we have a look at this zombie mutant? I think we did, yeah. That can go as well. Don't think we're going to be using that. And zombie women, I'm pretty much guaranteeing that we're not going to use this. We'll have a look at it and see how it looks, but I'm of the opinion that we're not going to be using this. Okay. So it's compiling shaders, and I think I'm going to head at this point because I don't want to have you guys sitting looking through compiling shaders. So if you've enjoyed the stream, hit subscribe, hit the like button, check out the description for links to my Discord, Patreon, and my previous game on Steam, which it would very much help if you added it to your wish list. Doesn't cost anything to do that, and it helps with the Steam algorithm. And we shall be back later at 8 PM Central Time, and I shall see you then. Thanks again, guys. Bye bye for now.